Using the law of sines, we need to show that in a triangle, a squared times sine b minus c equals b squared minus c squared times sine a. Now here, we will first specify the law of sines. Considering a triangle ABC, then the sides opposite to angle A, angle B and angle C are going to be represented by the letter A, B and C respectively in lowercase. Then the law of sine states that if we take the ratio of side A to that of sine of the angle opposite to it, this ratio will be equals to the ratio of side B to that of sine of the angle opposite to it. And this ratio is also equals to the ratio of side C to that of sine of the angle opposite to it. So this is the law of sine. So what we'll do to solve this problem, we will consider that these three ratios, let them be equals to a common constant lambda, such that now we can represent A as lambda times sine A. B will be represented by lambda times sine B, and C will be lambda times sine C. Now what we can do, we can replace this value in place of A, B and C. We can start either from the left hand side or the right hand side. So let's begin from the right hand side. So here we have b squared minus c squared. So in place of b, if we replace it with lambda times sine b, we're going to get lambda squared multiplied to sine squared b. Minus c squared, this will give us lambda squared multiplied to sine squared c, whole multiplied to sine of angle A. So we can, now taking lambda squared as the common factor, so we're going to get lambda squared multiplied to sine squared b minus sine squared c, whole multiplied to sine of angle A. Now sine squared b minus sine squared c, so that's actually sine of b plus c multiplied to sine of b minus c, whole multiplied to sine of angle A. Now what we'll do, we'll work with this particular sine of b plus c, because we know for a fact that in any triangle ABC, the sum of the interior angles A plus B plus C, so that's equals to 180 degrees or pi radian, meaning b plus c can be also represented as pi minus a. Now if we take the sine of the angle on both sides, we have sine of b plus c, so that will be equals to sine of pi minus a. Now sine pi minus a, that's a standard value of sine a. So we can say that in place of sine b plus c, we can replace it with sine a. So we will get lambda squared multiplied to sine a multiplied to sine b minus c. Now we also have sine a multiplied to, so that means finally we get sine squared a. Now what we can do, we can take lambda times sine a whole squared multiplied to sine b minus c. Lambda times sine a, we have already specified that this value is a, so we have a squared multiplied to sine b minus c, and this is the expression on the left hand side. Now, we have successfully shown that the left hand side of our expression is equals to the right hand side, hence proved.